Neo4j is a database. Unlike traditional databases, which store data in rows, columns, and tables, Neo4j has a completely flexible structure. Most importantly, Neo4j saves the relationships that connect your data. With Neo4j, each data record, or node, contains direct pointers to all the nodes that it's connected to. For example, if Bob is friends with Jane, that Bob node points directly to Jane through a stored relationship. This network of nodes connected by relationships is known as a graph. Most other databases, even more recent NoSQL types, don't save relationship data directly. They can figure out connections, of course, but they usually do this by searching through a separate data structure called an index. This lookup process, which has to be done repeatedly to find each connection, is an expensive extra step that makes these databases inherently slower than Neo4j for relationship intensive queries. Neo4j avoids these index lookups because its native storage layer is a connected graph. That's why we call Neo4j a native graph database. Over the past decade, Neo4j has made graph databases a key technology powering modern applications for hundreds of Fortune 500 companies, government agencies, and NGOs. Neo4j is used to detect fraud, enhance artificial intelligence, manage supply chains, unify data silos, and much more. Visit neo4j.com to learn more, or take a guided tour of a graph database use case in the free Neo4j sandbox. Neo4j, the number one database for connected data.
Welcome everyone. Ni hao, namaste. I'm Nick Vora, and on behalf of all the nodes at Neo4j, I'm here to speak about Graph for financial services with a special focus on using graph technology to advance our future against anti-money laundering and fraud detection. We often talk about this, that everything is connected, everyone is connected. If you look deeper, everything from your Grabs, your Gojeks, and your Ubers, the bank, our devices, our home addresses, the way we work, the way we go to work, everything is connected and in possibly more ways than we realize right away. Here at Neo4j, our point is that everything is not just connected, but it's naturally connected. If we analyze closely our behavior, the supply chains, the groceries that come to our home, the food delivery, medical research, our DNA strings, our behavior, customers, all of it is deeply, deeply connected to each other. Even as the world comes out of COVID, our dependency on each other to keep ourselves safe, our dependency on shared medical research, our dependency on improving vaccines. If we are to take a flight again for vacation, we are deeply interconnected. And that is a graph connection. If you analyze the traditional systems of the past, which include a relational, a document, a columnar, etc., they are great in analyzing discretely what your data is doing. They're great for fetching a value if you have a key. They're great for traversing through JSONs and JSONs. But your traditional systems may be stripping the context and the value and the connections within your data. Modern connections are not only utilizing data, but more importantly, they're using data and the relationship within that to derive a further context on what is possible from today. If you look at the business applications, right from personalization, data driven discoveries, research, fraud detection, social networks, compliance, risk management, anti money laundering, and so forth. Anything and everything that you wish to whiteboard first, in reality, is really a graph problem. And all the modern data platforms are waking up to the reality that having data is just not enough. You must make use of the context within the data, and that is by making relationships a first class citizen. World over, we see a tremendous growth in adoption across academics. There are more and more research papers. There are more and more developers, communities, meetups that are talking about graph database. Over the last 10 years, graph database has been the fastest growing category across all databases. And this is as per DB Engines. On the enterprise side, more than 76% of the Fortune 100 has adopted or are piloting Neo4j's graph database technology. 20 of the top 25 finance organizations, 3 of the top 5 airlines, Three of the top five hotel industries, telcos, logistics, all of the top Fortune 100 companies are using this. If you've ever sent money overseas, if you've ever taken a flight, if you ever stayed at Marriott, most likely than not, you're part of Neo4j databases across the world. Every single day, thousands of small, mid sized, and large enterprises are building new use cases and applications using Neo4j's graph technology. This is just a small list of who else is out there utilizing graph. I want to talk about a few particular scenarios that are very, very interesting. We might have heard of FinCEN files from the International Consortium of Investigating Journalism. The FinCEN files uncovered an industry level anti money laundering scandal in the US, and that entire work was possible in addition to other tools. They used Neo4j to link the relationships, identify patterns, and bring out that information. AstraZeneca. AstraZeneca is a leading global pharmaceutical company that uses Neo4j to trace medical records for patients, patient journey, and recommend proactively things and medicines that the patient must take in order to prevent further injury or disease. NASA is a very interesting example. The recent mission to Mars was fastened by over 2 years, and they saved millions of dollars because they were able to map all of that information using a graph technology on Neo4j. Worldline is Europe's leading travel and logistics organization, which deals with not just payments, but also the entire infrastructure around that. They're now using Neo4j to implement and modernize the entire structure and improving the passengers' overall experience. And the most special, and the one that we are extremely glad and humbled by to be a part of, is the COVID graph. As last year, we all witnessed what COVID was doing for us, there was an urgent need for the ecosystem to come around and develop solutions that would help us battle COVID and trace each other. I'm happy to report that we have been able to be a part of governments globally, including many governments in Asia, using graphs for good on Neo4j, not just to further research, not just to further the vaccines, but also keep all of us safe using contact tracing. Coming to financial services, there has been a rapid rise of connections, possibly as rapid as the increase in the data volumes itself. If you look at the network of the people, if you look at network of the assets, and if you look at network of the entitlements, we would cover the entire scope right from privacy, security, identity and access management to risk management, fraud detection, compliance, be it GDPR, be it any other compliance, or as basic as a customer 360. Who are we? We are Neo4j, the graph database company. We are the creators of the property graph database category. We'll talk about what a property graph database is later on. We are also the only organizations with over 450 people committed to advancing the technology of graph, with over 400 global customers and a very rich adoption by the financial services industry. It gives me great pleasure to let you know that we are now completely and fully present across Asia and across the Pacific, and we are here for you. Now let's come to the topic for the day, which is stopping credit fraud and detecting fraud with graph technology. Who are today's fraudsters? Is it an individual sitting behind a desk? Are there people who have just stolen somebody's card and going to shopping malls? Or are there devices who are acting on their own? Unfortunately, over the last many years, fraudsters have become extremely sophisticated. They're now organized in groups. They've created synthetic identities. Oftentimes they use the stolen identities to create those, and they no longer use their own devices, they use hijacked devices. There are many kinds of frauds that we see, including credit card fraud, including rogue merchants where the merchants are themselves involved in the fraud rings, which are probably some of the hardest to detect. And if you consider traditional systems of relational database and document database world, it's extremely difficult to identify fraud rings at the scale at which we're operating. We'll also talk about insurance frauds, e-commerce frauds. But as we all know, the most important fraud that we must be prepared for is the fraud that's yet to come. It's the fraud that we are yet to learn of. We must not be sitting on our knowledge of existing frauds, but must be equipped with a technology that can prepare us and alert us about the fraud that's coming. Now, let's analyze the world of fraud. There are tons and tons of people who are making their bread just because they deal with frauds. It's constantly evolving, it's simple and complex at the same time. Sometimes there's going to be a few players, and sometimes it's going to be large groups. Throw back to the FinCEN file, it was an industrial level fraud. It's often digitized, it's sometimes on paper, it's sometimes on the analog, and there's always the notion that they're always one step ahead of us. Now, let's look at fraud detection from a data modeling perspective. For us to accurately detect fraud, the tendency has to be to capture millions and millions of transactions and create huge data repositories. That allows us to identify anomalies if you know exactly what you want to ask for. Is a credit card being used at the same time in two different countries? Clearly anomaly. What happens if that's not the case? What happens if you want to detect a pattern? What happens if the pattern changes? And what happens if the pattern changes again? Remember, fraudsters are keeping one step ahead. A key part of fraud prevention is reacting to the patterns. We must have systems in place that help us detect those patterns and respond and do it fast. Let's look at the underlying technology choices. If you right now have a relational database, you're possibly able to ask many questions, and you possibly know of a lot of anomalies, and you have a question bank somewhere that tells you what the possible frauds are. But how do you prevent the fraud that you don't know about? How do you prevent the patterns in real time when the connections are in millions and billions of records? And you do it by modeling your data as a graph and using a graph database technology such as Neo4j. Let's look at some of the very prevalent fraud examples. Fraud rings, we spoke about this a bit earlier, extremely difficult to detect, and I'll share why. A leading market research firm has said it's no longer sufficient to just consider using the traditional technology because the criminals have stepped ahead. Now, the typical methods that you might have today would either be endpoint centric, navigation centric, or account centric, which is to say you would either look for fraudulent devices, fraudulent networks, IP addresses, or fraudulent or a mismatched user to an account. For example, a new bank creation would be an account centric fraud detection method. The good thing about this is it works when you're looking for discrete analysis. The weakness is if they start working together, there's very little we can do to stop that today. We wouldn't be able to detect fraud rings if they have fake IP addresses combined with hijacked devices and combined with synthetic identities. That's not going to show up on our map. And let's see why. We usually have a normal behavior that we let pass, and then we investigate everything outside of it. Investigation is often manual with risk officers, and they are inundated with positives, and false negatives. When it comes to anomalies, we can ask the right questions. However, if there is a pattern within the normal behavior of fraud, we would completely miss that. And that is where fraud rings are created. So, to supplement our discrete analysis, to build on what you already have, to improve your accuracy and reduce your false positives and false negatives, we must look at connected analysis, which is across the channel, linking all the entities, linking all the parties. How would a fraud ring look as a graph? You have three account holders, and they have their own social security number, their own credit card, their own bank, etc., etc. What has happened here is that these users are sharing phone numbers, addresses, and social security numbers. On first sight, without a graph technology, it seems a perfect normal behavior unless you start modeling this on a graph database, which is when you start seeing the results. Credit card fraud. A very popular fraud method on credit card is testing. And this usually happens either for a rogue merchant, if you've manually skimmed an ATM card, or if you have done a data breach online. This is where the fraudster makes multiple small value transactions before making a big transaction. Combining all the small transactions on a graph system, it allows us to prevent the big transaction down the road. A second follow-up to that would be fraud origination and assessing the loss magnitude. If you look at different patterns of frauds that have been reported at different computer stores, etc., etc. And if you trace that back on a graph database, you would end up finding that these frauds might have a common source of origination, which in this case is a gas station. Let me talk about the value that our customers in London and New York derive from this. They're a global financial services firm with trillions of dollars in assets. If you want to know the name, you're welcome to LinkedIn us, and I'll call you and I'll give you the name. They had varying compliance, risk, and governance considerations, and they needed a system that would scale to trillions and trillions of transactions for fraud and simplify the process of chargeback. After implementing Neo4j, they've been able to lower the TCO by simplifying the entire credit risk analysis by reducing the number of man hours and teams responsible for manual work, for fastening the process of new creations, identifying entities uniquely, and they have saved billions by reducing the chargebacks and frauds. And all of this is built for real-time, high-scale, trillions of transaction scale. Coming to the second conversation for today, using graph technology for anti-money laundering. Here's a typical framework that we at Neo4j believe you should use. You will have networks of people where you can detect what's happening. You put more and more data in to create a model using Neo4j's graph data science. And as that model matures, as you use it more and more, patterns start emerging, and you can then use the Neo4j visualization platforms to start looking at what's happening. Processing transactions for AML involves usually two steps. First is let's resolve the identity and then flag the suspicious activities. And then that goes to a team that reviews all the flagged activities. Most of AML processes today involve a high degree of false positives and negatives, which means a lot of account opening, a lot of business transactions take anywhere between 5 to 10 days to just identify any possible leak. Why is it so hard? If you look at the data sources, right from SWIFT to global sanctions to negative media reports, there's a lot of data that's coming in, and you need to map all of that data. And this data is of extreme scale. Think of every transaction happening cross-border globally, and you can imagine the kind of scale you would want to deal with when it comes to AML. This is across consumer banks, across geographies, across credit cards, wealth management, investment advisory, insurance underwriting, etc. At extreme scale, how would you as a system uniquely identify the entities and with a very high level of confidence so that you reduce your false positives? Typical text analysis on a Hadoop or a Spark or a data lake or document database would do text analysis. Similar sounding names, similar looking names would be clubbed together, but they do not deal with the context of that entity. They do not deal with the connectedness between the entities. What graphs brings to the table is a graph traversal and a similarity scoring algorithm from Neo4j's graph data science module that leverages not just the similarity in text, but also the similarity in network. So why should you use graph for entity resolution? As I said earlier, entity resolution done right is half the battle won for AML. Graph stores the data as connected data. And if you're looking at anti-money laundering patterns, you're looking for connections. You can connect the PII data on write, on ingestion, via ACID as fine-grained first-class relationships, which makes rest of the process very, very easy. And it's relatively very easy to pick up the technology and the language as you're building out your use cases. Add to that, for the team who's assessing the flagged suspicions, there's rich visualizations built in with Neo4j Bloom, with our partner Linkurious, and custom builds and custom integrations, right down to Neo4j's connector for Power BI, Tableau, and other popular BI systems. Some of the AML scenarios that we provide out of the box is in addition to the entity resolution, which is the shared personal attributes. If you want to look at layering, behavior, circular payments, cross-border circular payments, if you want to flag high-risk transactions in a known geography, if you want to look at concentration, velocity, rapid movements, all of these are scenarios available out of the box by Neo4j solutions. Brazil's largest bank, which is 38 on Forbes Global 2000, is a big customer for Neo4j. Before they started working with us, they had high scale, and they were anticipating a 10x increase in the scale, right down to tens of trillions of transactions. The data silos they had made it extremely difficult to assess the creditworthiness for new applications or to detect fraud. The impact was not just on new business and sales, it was also on penalties due to non-compliance. With Neo4j and with the credit monitoring and fraud detection application, they have now grown to over 93 trillion relationships across 2,000 analysts working for the bank, all on the Neo4j platform, avoiding heavy penalties and reducing fraud in the millions of dollars. Why Neo4j? If you look at the property graph model, the whiteboard model is the physical model. If you would pick up a pen and start drawing a flowchart, you would most likely be able to do it on Neo4j. If you look at different models of sales, relationships, org charts, it's very agile, it's easy to understand, and it's easy to collaborate. The speed is incredibly quick. If you look at what we can do with just 30 threads, is we can have anywhere between 36 to 60 million hops per second. Try doing that with a relational world, and your cloud bill will go out of the box. We are native from the start. We provide a native graph storage as well as a native graph query, which means that you're not just getting the visualization, but you're getting optimized reads in real time, and you're getting asset writes. In addition to all of that, you also get Neo4j for data science, which is where you combine your database, you combine your exploratory tools, and you combine the JDS modules, which comes with over 50 different algorithms across pathfinding, centrality, similarity, detection, and a lot more. And all of this built for scale and built for enterprise. We are the 800-pound gorilla in the graph database market, with over 20 of the top 25 global financial institutions using us in production. With that, I thank you for your time, and I look forward to hearing from you.
There are many types of databases today. The tried and tested relational database, the new and popular document DB, and many others. And all of these have their strengths. But one place they all fall short is in handling complex connections between your data. Sure, any database may be able to return friend of a friend queries of 3 or 4 degrees, but what if you need 20 degrees and need it quickly? That's where Neo4j comes in. Unlike other databases, Neo4j Graph Database doesn't need to compute the relationships between your data at query time. The connections are already there, stored right in the database. Because of this, queries of deeply connected data are orders of magnitude faster. We get used to the limitations of the tools we work with. Neo4j blows those limits wide open, enabling queries never before imagined at speeds never thought possible. That's why Neo4j has become a key technology driving business-critical applications for hundreds of Fortune 500 companies, government agencies, and NGOs. Learn more at neo4j.com.